Hello, we have already defined the region for this course, Geography of Asia. We sometimes call this region the Monsoon Asia. Obviously, Monsoon Asia is characterized by the monsoon climate. So in this lecture, we discuss the monsoon climate. We first define the monsoon climate, then we discuss origins of monsoon climate. Then we discuss why is monsoon climate is so strong in Asia. Finally, we look at some regional variants of the monsoon climate in monsoon Asia. The definition of the monsoon is a current air blowing fairly steadily from a given direction for a few weeks or a few months at a time. These seasonal reversals of wind are also accompanied by corresponding changes in precipitation. The word monsoon originates from Arabic word Monsoon. The Chinese words for monsoon are 季风, which means seasonal winds. So this is a climatic pattern associated with seasonal changes in winds and related weather conditions. Monsoon climate occurs in all subregions of so-called monsoon Asia. Its intensity varies at different locations, also in different times. The origins of monsoon climate can be attributed to several factors. We start from differential heating and cooling of land and ocean, which gave rise to differential temperatures, different pressure systems, eventually that also caused movement of air and resultant precipitation patterns. Now, let's look at each of these factors in turn. Differential heating and cooling. We know that the sea heats up slowly and cools slowly. At the same time, land heats up quickly and cools quickly. And this difference is simply because different characteristics of water and land. Differential heating and cooling process eventually gave rise to different temperatures of land and ocean during different seasons. During the summer, because the land heats up quickly, so the land will have higher temperature. Ocean, since water heat up slowly, the ocean will have lower temperature. In the winter, it is opposite because land cool off quickly, so land will have lower temperature. At the same time, because the sea cool off slowly, it will have relatively higher temperature than land. This map shows an isotherm in the northern hemisphere summer. An isotherm is a line that connects all the points that have the same temperature. For example, this isotherm is 70-degree isotherm. It connects all the points that has 70 degrees Fahrenheit. In the summer, the isotherm in northern hemisphere an ocean bend southward. That means that on ocean you have lower temperature than land at the same latitude. Why that happened? Let's see. This isotherm is 50-degree isotherm. One to the south is 60-degree isotherm, and one next to it to the south is 70-degree isotherm. So the isotherm move from the north to the south, the temperature become higher. Therefore, when you look at this particular isotherm, 60-degree isotherm at the same latitude on land, this location, obviously at this location on land, the temperature here is higher than the temperature on the same degree of latitude on ocean. So at the same latitude, the temperature on land is higher than that on ocean. So that is what we talk about differential temperature between the land and the ocean in the summer. Now, in the winter, it is opposite. In the winter, the isotherms on the ocean bend northward. That means that all these points on ocean at the same latitude would have the higher temperature than land. For example, at this latitude, the temperature on ocean is 40 degrees Fahrenheit. At the same latitude, the temperature on land is between 30 degree and 20 degree. So its temperature on land for the same latitude is lower than the temperature on ocean for the same latitude. Again, this verifies our early statement that in the winter, the temperature on ocean is higher than that on land. Differential temperatures eventually gave rise to differential pressure systems on land and ocean. In the summer, the land has higher temperature, so it warms up the air near surface. When the air becomes warmer, its density becomes lighter, it tends to going upwards, forming low pressure system near surface. On the ocean, it is opposite because ocean has a cooler temperature, so the air near ocean becomes cooler. When the air is cooler, the density is higher, it sinks down, forming high pressure system. So in the summer, you have a higher pressure system on ocean and a low pressure system on land. In the winter, it is opposite because the land has lower temperature, it makes the air really cold and the density is really high and sink down, forming higher pressure system on land. On ocean, it is opposite because in the winter, the ocean temperature is warmer, the air is warmer too, so the density is lighter, so the air will going up and forming low pressure system. So in the winter, the land has higher pressure system and ocean has lower pressure system. And this map shows the July pressure systems and the surface wind system. Let's look at, see, in northern hemisphere, we know that July is summer for northern hemisphere. So on ocean, we have a higher pressure system. On land, we have a lower pressure system. The high pressure system on ocean, and a lower pressure system on land. For January, this is the winter for northern hemisphere. So we have a higher system on land and a lower pressure system on ocean. This kind of a differential pressure system eventually have a strong impact on the wind system, air movement, and the precipitation. In the summer, because you have a lower pressure system on land, and also you have a higher pressure system on ocean, therefore the air will blow from the high pressure system toward the low pressure system. In other words, the wind will blow from the ocean toward the land. Now, the ocean is a source of water. When the air blows over the ocean surface, it will pick up a lot of moistures and dump those moistures on the land in the form of precipitation. So when wind blows from ocean toward the land during the summer, it's a lot of time to carry a lot of moisture forming precipitation. In the winter, because we have a high pressure system on land and low pressure system on ocean, the wind will blow from the land toward the ocean. The land is not a good source of moisture, so the wind will blow from land toward ocean. Normally is dry, so during the winter, the wind that carry not much moisture from land toward ocean will not generate a lot of precipitation. On this map, we have seen this map before. Now let's focus on the wind system. In the summer of northern hemisphere, we have a high pressure system on ocean and a lower pressure system on land. Therefore, the wind will blow from a high pressure cell toward the low pressure cell, blowing from ocean toward the land. In the winter, we have a higher pressure system on land and a lower pressure system on ocean. The wind will blow from the land toward the ocean. Okay. Because of this kind of reversal of pressure system and the wind, you can really see that in northern hemisphere in the summer, the wind will blow from the ocean toward the land. Therefore, for those regions, summer is a time when the land will receive a lot of precipitation from ocean. In the winter, in East Asia, the wind will blow from land toward ocean. It does not carry a whole lot of moisture, so it's dry and cold. Why is monsoon climate so strong in Asia? We have talked about the contributing factors to the monsoon climate. We talk about the land and ocean. Now, in Asia, the Eurasia continent is the largest landmass. The Pacific Ocean is the largest ocean along with the Indian Ocean. So the largest landmass and the largest water bodies, between them is a differential heating and the cooling process and the resultant differential temperatures, pressures, and the related air movement and precipitation. This kind of mechanism developed to extreme. You have very large annual temperature differences as a result of this largest landmass and the largest water bodies. This map shows the annual temperature range, which is the difference between the hottest and the coldest monthly temperatures. Now let's look at in northern hemisphere at this latitude, the difference between the July monthly average temperature and the January monthly average temperature is depicted on this map. At this latitude in Asia, at this latitude, the annual temperature range is about 60 degrees Fahrenheit. For the same latitude in North America continent, the annual temperature range is about 50 degrees. So as you can see that for the same latitude, the difference between the hottest and the coldest monthly temperature in Asia is larger than that in North America. This is evidence that this kind of the mechanism that contribute to the monsoon climate developed too extreme in Asia, and that's why monsoon climate is very strong, very typical in Asia. Finally, let's take a look at regional variance of the monsoon climate. There are many contributing factors to the regional variations of a monsoon climate. These are the Himalaya mountains, the Tibetan plateaus, the oceans, the island chains. These geographical features divide and block wind flows that eventually create regional variations of the monsoon climate. Here first you have South Asia monsoon, you have the northeast monsoon or the winter monsoon that blow from land toward the ocean. Also you have a southwest monsoon or the summer monsoon that blow from Indian Ocean toward the land. The winter monsoon in South Asia is not very strong because the wind blow from the land toward the ocean. The wind does not carry a whole lot of moisture. In addition, the temperature on land is not that low. So it does not generate very low temperature, does not generate a whole lot of moisture precipitation, so it does not have a whole lot of dynamics on the regional basis. On the other hand, southwest monsoon blow from ocean toward land that carry a lot of moistures from ocean toward the land and in the form of a precipitation. So in South Asia, summer monsoon or southwest monsoon is very, very dynamic. It gives generates a lot of life-giving rain and flood. So we're going to discuss this later on when we discuss the geography of South Asia. East Asia monsoon. Here you have a northwest monsoon or the winter monsoon. The wind will blow from the land toward the ocean. In East Asia, the winter monsoon comes from a very high latitude. It does not carry a whole lot of moisture, but it has a very low temperature, so it creates very harsh winter conditions. Then you also have southeast monsoon or summer monsoon. The summer monsoon blow from ocean toward the land and bring a lot of moisture to the land, and that is what makes East Asia a very favorable place for rice growing agriculture. Southeast Asia monsoon. Here you have a northeast monsoon or winter monsoon. Winter monsoon is basically the continuation of East Asia winter monsoon, but the winter monsoon in Southeast Asia is largely modified because the very harsh and dry winter monsoon, when it blow over ocean, it was modified and began to pick up a lot of moisture, and a lot of moisture will be dumped on the land of Southeast Asia in the form of precipitation. Southwest monsoon or the summer monsoon in Southeast Asia is the continuation of the summer monsoon from South Asia. It blows over a large ocean areas, also carry a lot of moisture and dump those moisture on land in the form of a precipitation. So both winter monsoon and the summer monsoon in Southeast Asia is also significant in generating variety of weather conditions. When we talk about the monsoon climate, there are some other factors we did not discuss, such as existence and circulation of upper jet streams in the troposphere. In this class, we do not discuss those more complex factors. So in summary, in this lecture, we defined monsoon climate. We also talked about origins of the monsoon climate. We had mentioned differential heating and cooling, and differential temperatures and pressures, and resultant wind and precipitation patterns. We also explained why is monsoon climate so strong in Asia. Largely, this is because of the contrast between the largest ocean and the largest land mass. And finally, we also discussed regional variance of the monsoon climate in Asia. Basically, the three subsystems of the monsoon climate in the three subregions of Asia. Thank you very much. I see you next time. Goodbye.